Alright, I'm starting cloud-based software.
Okay, so we're not doing Kokomo?
We're not doing Kokomo.
Got it, thank you.
Cloud is made up of very large number of remote servers. You all know that, right? You know what the cloud is?
It's someone else's computer.
It's someone else's computer. Well, someone else's many computers.
Many computers.
Cloud-based servers are virtual servers. Why are they called virtual servers? What does that mean?
You don't have the physical access?
No.
I don't know.
What do they mean by virtual servers here?
It's they're away. Hidden. Like you don't see them.
No,
They're
no.
abstracted away.
How are they abstracted? What does that mean, though?
But you don't need to worry about how they work. They just work.
Oh, that's true. That means that's the idea of cloud. But why are we calling it a virtual server? That's not why we call it virtual.
Have you seen Kamala Harris's explanation?
I'll tell you what it's not. A normal. What is Kamala Harris's explanation?
Have you seen it?
Sorry.
It is so funny. You have to watch it.
Servers?
It's like 30 seconds long.
Not now. What is it about servers?
It's her explaining what the cloud is.
Okay, I'll look it up.
It's very personal. Very personal.
Fine, but I want to go out now. I'll look it up without now. Oh, look at now. Oh, it's our class. No, it won't work. Well, it won't work. People will be engaged.
Take you over to basic.
File cabinet that's locked and.
No, guys, don't do that now. No. No, it's not 30 seconds. Guys, I want to explain what a virtual server is.
It's 30 seconds.
I don't care. Virtual server, it means, guys, quiet. What do you say? Yeah, what do you think?
It's server and virtual machine that are on.
Oh. Instead of on hardware, it's not on metal, yeah. You said right.
Very good.
It's a server means that it's in a virtual machine, which means essentially like this. Normally, when we think of a server, we think of you buy a machine that's built as a server, not as a desktop, it's a more powerful machine. And then we would think that the cloud means you rent that server. Now you have that server, you rented that hardware and you can use it, and it happens to be in Virginia, but you're using it. That's not a virtual server, that's an actual server. A virtual server means you have a very powerful machine. And on the machine, you create
Virtual machines.
You create, let's say, 10 servers. And then you can rent or sell those servers to different people so that I and you are both hiring a server from the cloud, and we don't even know. We might be on the same hardware or on different hardware. We have no way of knowing. And that means that the servers have to be
Independent.
contained. They have to be what's called contained, that's the word. Containers, we make containers, which means they have to be isolated one from the other in a very good way. Because what could you do? Let's say I happen to let's say I rented a server from Apple, and it happened to be on the same hardware as the iPhone of some person. So if I could somehow break out of my virtual machine into the actual machine, I would maybe be able to get access to information that's on the physical machine, but it's not in my server. So the idea of a virtual server is a server in software as opposed to a server in hardware. We create the feeling, the look and feel of you having your own hardware, but we don't actually give you your own hardware. Now, when you buy something from, let's say, Amazon AWS, you have actually several options. One option is to buy a server. No, but even then it's going to be a virtual server. That's my point. If you buy a server from,
But you can get that. You can run that.
yeah, but you don't. Let me explain. What you're getting is a raw machine. You're getting an empty machine, and you can put anything you want on it. But you have no way of knowing if that machine that you have, it could be on some gigantic computer that has a billion, piece of memory and hundreds of CPUs, and you're just getting part of that machine. They're not giving you an actual metallic box.
It says that EC2 dedicated host is a physical server fully dedicated for your use.
Physical server, it says that?
That's what it says on AWS document.
What is it called?
What?
Okay, so I didn't know that. What's it called?
The Amazon EC2 dedicated host.
Amazon what?
EC2.
EC2.
Yeah.
EC2, alright, I'll look that up. Fine, anyway, that's not but you can also get a virtual machine where you hire a server and it's empty. And then it's your, Malcolm, please, Malcolm, I can't go like this all the time. A virtual machine means. Again, you get the machine and you install on it whatever you want, Linux, Windows, whatever. You can also. Get a machine that has already Linux installed on it. You can also get it that has Linux on it and it has all kinds of applications that you need. You can also do a third thing, which is that you can just get like database service. You're not actually getting a whole machine, you're just getting an SQL server. And then that could also be done virtually. You could have a large SQL server. And you're just using part of it, and you feel like you have your container on that SQL server. Okay, that's the idea of virtual. What's the big advantage of all this? What are the advantages of a virtual machine like this?
Cheaper.
Not necessarily. It could be cheaper to buy your own and put it in your basement. But still, there is a financial consideration. What's the financial consideration?
Physical versus virtual, or servers versus cloud?
Owning a server versus renting a server.
There's a couple costs of, it depends on the cost, but usually it's gonna be cheaper to rent it out unless you have security.
No, not necessarily cheaper. Like I said, you said cheaper before, it's not necessarily cheaper. What what is better about it is that you don't have a lot of upfront costs. If you want 25 servers. You can just pay your monthly fee and eventually you'll pay lots of money, but in the meantime, you didn't pay that much. Whereas if you wanted 25 servers for your startup, you'd have to go out and buy 25 servers, it's a lot of money up front. So you amortize the payments, that's one reason. You can amortize the payments over a long period. The second advantage is that if you all of a sudden have let's say the CEO got an interview on CNN. To talk about his company's website. Now, all of a sudden, because millions of people saw that, there's going to be a lot more traffic to your website. So for the next 36 hours, you need a lot more servers. So you can just double or triple or multiply by 100 the number of servers you're renting, and you can rent them just by the hour. And then you can remove them when new traffic goes down, which you can't really do if you would own the machines. Now, once we talk about that, what does that require from you? How do you, let's say you have installed all kinds of stuff on your server, and all of a sudden you decide in 1 hour I need 100 more servers. How are you going to install it all?
Docker.
You need to have like containers they're called Dockers. You need to have some automated system for installing and creating your server on the fly, as you want a script that you can run. Used to have something called chef scripts. But that doesn't matter, there's different methods of doing this, the concept is you need a way of bringing up your server. In an automated way, that I don't have to actually manually go in and install things and configure things and press yes. I gotta be able to install what I need and duplicate one server to the next. And even write a script to create 100 servers. So. All that is necessary for cloud to really be, that's necessary for cloud to be efficient. And the advantages of cloud we talked about already. Okay. So that's what this says here. Cloud servers can be started up and shut down as demand changes. You can rent a server and install your own software. You could also pay for access to software products. That's what I was saying about an SQL server. You don't necessarily need an entire server with that. You don't care what the operating system is. You don't care about that. You just care that you have an SQL, you have a port that I can connect to remotely and do my SQL queries and put data in there. So you're just getting service. Okay. You can also pay for access to services like a credit card check. You know, a whole complicated service, not just not a raw SQL empty database that you have to populate, but a whole service, like I said, like credit card validation payment system. You know, not every website, no website company, no website. Charges your, maybe Amazon, but no website basically charges your. Credit card themselves, they hire a service that deals with banks and all credit cards. Okay, so what do we see about the cloud? It's scalable, which we explained, that means that you can expand it. Elastic. That means I guess you can change the configurations easily. You can have scripts that change the configurations. Resilient, if one fail, you know, you basically have guaranteed uptime. When you hire a server, if you have your server in your basement, it could crash. Well, that's the other thing I was gonna say, if you have your own servers, you may have to have an in-house person who knows how to handle servers. And even if you don't have an in-house, you hire it out, and then you still have to pay somebody to come, when your servers crash, you may call somebody and say, I need you to come fix my servers, and he says, I can't come till next Tuesday. That's not so good, but when you hire from Amazon, they're kind of guaranteeing you uptime. So we said scalability is if the load increases. Elasticity is similar to scalability, but it means that you can also go down. Scalability literally means that you can expand. Doesn't include the concept that after 36 hours, your traffic went back to normal, you want to be able to decrease, so that's elasticity. Resilience means that you can design your software to tolerate failures. For example, you could have there are multiple concurrent copies of multiple servers that do the same thing, and have some kind of what's called a load balancer. And then if one fails, the other ones will pick up the load. So here we're talking about the benefits. So here's what we said: the cost, you save the initial capital costs. Like I said, you amortize the payments. You just pay a little bit. You have to pay a little bit every month, and it may add up to be more. In general, you know, I don't like services. Like if you pay to Google, you know, $1 a month for an extra 15 gigabytes of memory. She says nothing, but over 3 years, that's $36. For $36, you could buy twice that much memory on a flash drive, and you know, you could get that much space cheaper if you would buy it. Right? Services are a creeping expense. Creeping.
Also pretty creepy.
It could be creepy. Right, nowadays you can pay a lot. I finally, and I'm slowly entering the world of payments because my kids wanted Spotify.
That's how they get you, by the way.
So now I got a family membership of Spotify, so I have Spotify. But I don't have Netflix.
Good for you. Spotify's kind of it's utility at this point.
It's just for music, no? I mean, and
Yeah, music's a utility.
music and podcasts. Yeah, it is kind of nice that I can listen to any podcast. But
Without ads.
without ads, and music without ads. Although I find that a lot of times you have to really know what you're looking for at Spotify. If you just like type in the name of the song you want, it can give you not the right version of the song.
Yeah, it's hard to find some.
No, if you give you like a live recording and you want the album, that's pretty good. Okay, even if it's the same person, the same song, almost the same song. And it doesn't even show you, you have to you can't even scroll for it, you have to type in the name of the album and then you can get it. That's what I found. Anyway, startup time. Right? You don't have to wait for the hardware to be delivered to your shop and put it in your basement and put up wires on it. There's this TV show that I recommend kind of. It's called Silicon Valley,
Oh my god.
but it's not it's a little bit crude at some parts. But it's very funny, and it's very authentic to the way the world, the way Silicon Valley works. And in that show, they have a very small startup with like 3 people, and one of them is the server guy. And he, takes the garage and he builds the whole server room there. You have to have your servers. Of course, nowadays you wouldn't do that. Server choice. If you find that your servers aren't powerful enough, you can also upgrade. You can say, when you rent your server, you could say it was this chip. And now I could say I want a chip that's twice as powerful. Or I want, instead of 2 cores, I want 6 cores. And you just upgrade it, you just tell them, I want more cores, and they give you more cores, and you don't have to do any new installation. They migrate everything for you, they take care of it, you don't, or, you know, it's all just like turning the knob of a oven to a different temperature, and just do what you want. You can also have short-term requirements for load testing, right? That's actually very important. You need to, when you make a website, you wanna test load, you wanna know if like 1 million people come, will my service crash? How much can it handle? So for testing purposes, I may need a special server to try to connect to my server. And I'm not gonna use that server normally, to simulate all the clients. So for the next week, I need a client server, I need a server to do 1,000 connections a second, you know? And that, I don't wanna keep that around forever, I just wanna do it for this testing period. Distributed development, if you have a distributed team, you have some people in India, some people in Israel, some people in America. If you're working on the cloud, then it doesn't matter where they are, even their testing, their development environment is in the cloud. Then you can be on vacation and work, you can be in a different country and work, and your team can be distributed all over the world. People nowadays, it's pretty common to have people working in India and America and Israel. So here we're talking more detail about a virtual cloud server. They run on underlying physical computer. Plus a set of software packages that provide functionality. A virtual server is a standalone system that can run on any hardware in the cloud. The run anywhere characteristic is possible because the virtual server has no external dependencies. We use virtual machines. There's something called a hypervisor, which allows me to have multiple operating systems running on one machine. If you use a virtual machine to implement virtual servers, you have exactly the same hardware platform as a physical server. In other words, virtual machine is to give you the hardware, well, really virtually the same hardware. I don't know why exactly the same. I would say virtually the same.
Is it no more?
Here's a picture. This picture speaks 1,000 words. Here is one method of having multiple servers on one hardware.
That's a lot of words. But also, what is a picture of 1,000 words worth?
1,000 pictures.
Right.
Okay. If we have the server hardware, this diagram is showing you like a computer. First, you take your hardware and you put on it some operating system. This is one method, there's different methods. One method is you put on an operating system, let's say put Linux on it. And then onto that, you put something called a hypervisor, which allows other operating systems to be on top of the Linux. So then I put on top of it a guest host, let's say a Linux and a Windows, another Linux, another Windows. I can maybe have 10 virtual machines, all on top of this hypervisor. And then I can rent this virtual web. This is a virtual web server. This is a virtual mail server. So this software here is different software from this software. And this is software to create a web server, and it's on a Linux machine. This is software to create an Outlook mail server, which obviously has to be on a Windows machine because Outlook is a Windows feature, Windows software. So, but you see, I have two different operating systems on one machine. And when you rent something from Amazon, you might get exactly this. You might get just one of these, for example. Now there's a different system, which the picture looks kind of the same. Here we have the operating system. Now we call it something called a container manager. Instead of calling it a hypervisor, we call it a container manager. It's a different technology. And we have different containers. This is what he was talking about. This is what Tusk was talking about. When he said, what did you say? Tusk, you left?
That's what do you think?
He left. He said, he said containers, but he also has another term, Dockers.
Kamala Harris.
Dockers. Docker is a type of container. It's following the container concept. It is a container. But the idea is like this, that you have a package of you see here your server software. Here you had an actual operating system. and then you put the server software. Here, you have a container manager, which you're actually using the host operating system. So actually, what can we say is different about this? How is this picture different from the previous picture? Here, you have a Linux operating system and a Windows operating system. In this picture, you do not have that. What do you have?
Just the host of us.
You just have the host OS. You have one operating system. You have multiple containers, but they have to be all using the same operating system. So I couldn't have a Linux machine here and a Windows mail server here and containers. What?
The container manager.
Container command does not take care of that. Containers are.
Why can't the client do it? in his
They're within the operating system.
software? Why can't the client do it in his software? Like if you tell him this is like a Linux based thing, so he translates it in his own software like that. So
No, you're saying he could, what you're saying is like, in this container, if this is, you're saying if this is a Windows machine. Couldn't he create in the server software like
yeah, another level.
a simulation of a Linux machine?
Yeah.
You could, but it would be very slow. You couldn't, it would be very slow, it wouldn't be a real Linux machine. The whole thing with this hypervisor thing kind of does a miracle. I mean, when it first came out, it was considered like a miracle. Because it allows this Linux operating system here, yeah, to directly access the hardware. In other words, it sort of like drills a hole, this hypervisor provides a hole to get through this operating system, get directly to the hardware. So that this is sort of working on the hardware without having to be translated through another operating system to slow it down. That's the idea. It drills down, the hypervisor, this system lets you get directly in. Whereas in this picture, containers, not at all like that. It's these containers are using this operating system to get here. They don't drill through. And the container manager his job is to separate the the side effects of between them. In other words, this container should have no side effects on the other container. Puts up a wall of separation between them, so that even though they're both using the same operating system, if one crashes, you can't possibly crash the operating system so the other one will crash. As that's the fear. The fear is that if container 2 somehow causes the operating system to crash, well then container 1 is gone. And this could be client 1, this could be client 2. Why should I lose out on my server because some other client did something crazy? So the whole job of the container manager is to isolate the 2 containers to prevent the possibilities of one crashing the operating system at all. Can't possibly crash the operating system. In this system, I could crash the operating system in the hypervisor system, but I wouldn't affect the other guy because I would be crashing my guest operating system. I wouldn't be crashing this operating system. Containers are usually megabytes in size, whereas virtual machines are gigabytes in size. In other words, this is a whole machine, this Linux thing. It's like a whole setup of a computer, just like it would normally be an install, and that takes gigabytes. The container is much more lightweight because he's using the existing operating system. He's just a partition within the operating system. Here, isolated application services where each user sees their own version of an application. That also is true. I could even have like this container manager, like everything running on this could be the same thing, could be SQL. And then I'd have my SQL, you'd have your SQL, and it would be separate. Anyway, that's the idea. Docker containers were developed by Google around 2007. But containers became mainstream 2015. An open source project called Docker provided a standard means of container management that is fast and easy to use. So if you use Dockers, then you're using a container manager. And you can even get pre-created containers. instead of building your own container to with whatever things you want, in it, you can just like download a container for what you need. Download a Docker for what you need. Docker is a container management system that allows users to define the software to be included in a container as a Docker image. And then I have that image and I can duplicate it. It also includes runtime systems that can create and manage containers using those Docker images. So you can like download an image that somebody else created theoretically. Or you can create an image and then distribute it among all your servers. Or among all many different places. It's particularly useful for developers. In a company, as a matter of fact, any company that you work for after you graduate should be using Docker or some form of containers. And if they're not managed correctly.
Really?
Why? For what purpose are they using it? You want to develop, let's say that everybody is working with Visual Studios. And then Visual Studio comes out with a patch. So I update my Visual Studio with the patch because I want to have a newest version. But you didn't notice the patch came out, so you didn't, or you put on snooze and you didn't update. Now you write software that doesn't, and it's not compatible with my software because my software is written for the new system with the patch, or the operating system changes. Better example. Mine works with the new operating system. Yours works with the old. So we don't want that. We want all the developers to be working on the same, in the same environment. So we create a single container image and we distribute it to everybody. And when there's a change, we update the image and redistribute it. So it's fast, it's efficient and fast, and we guarantee that everybody is writing code with the same configurations on the computer. So many times it happens that a person writes code and says it works on my computer. How come it doesn't work on your computer? I don't know. Don't figure it out. Well, it may take hours to figure out what the difference is. It may take days. You may never figure it out. Why? What's the difference? If you keep consistent installations, you don't have to have like a guy walk around to all the computers and make sure everybody did the install. They're all working on the cloud, and the cloud is being updated with your container in the cloud is being updated. Anyway, that's the idea of containers. So yes, every company nowadays, as far as I know, should be, I should say like that, using containers. I don't know a reason why not to do it. There might be, there might be, but I don't know why. Here's just a picture. I don't quite understand this picture, so I'll skip it. But they're Docker files, there's a Docker host, registries. It doesn't really explain that much. Even here, he tries to explain it. But the Docker files are images, but then it's an image. Anyway, I'm not going to expect you to know exactly how to manage a Docker system because even what's written here is not enough to know really anything. You have to use it to know it.
But Docker.
You have to use Dockers to be able to understand it. It's hard to explain without using it.
It's something that's like with boats, the boats, right?
Boats?
Yeah, the picture of Docker's,
If you never used a boat, it's hard to explain what it is. Yeah.
I'm talking about Docker, it's a boat.
Dockers?
You said Kubernetes.
Well, a boat needs to be docked. Is that what you mean? You wear boat shoes on a dock.
Good looking ways.
Come on, guys. Nachum, please don't distract us.
Whale boat. How many whales carry cargo on them?
The boats have a face.
A lot of them actually, with the face. It's taken us, and actually got for the fish, the fish in the ocean. That's so bad. I think home Docker.
So you see here that the Docker has all the tools that you need to run software that you want. Dockers have benefits of solving software dependencies. You ship your software with the image that it needs to be run. Instead of shipping your product as a standalone software, you can ship a container that includes all the support software that your product needs. Let's say your product needs a certain version of some other software, so you'll ship that with it in a container. We provide a mechanism for software portability across different clouds. They can run on any cloud provider, as long as the Docker daemon is available.
Simple and personal.
They're used by companies that use DevOps. DevOps, what does DevOps stand for?
Developer operations.
Development operations. Well, what's the concept? What's the difference between development and operations?
Oh, it's like a business technical stuff.
Well, I wouldn't call it business.
Not business.
It's not business. Technical, well, development is pretty technical. Explain. Yeah, use the right semantics, that's what I want.
Yeah.
Structure of it.
I want the right semantics. When you speak, you need to use the right semantics. That's what speaking is all about.
DevOps is when the same people are responsible for writing the software and running the software.
The
Right?
same people, yeah, ideally the same people or the same team.
Yeah.
A lot of companies have like a, what you call an IT department. That like, if I need a certain piece of software to get to work on my development. Then you don't have permission to install that on your computer. The IT team needs to install it on your computer. Your computer is locked from you. We don't want everybody just putting anything. You need permission from the IT team. And then if something goes wrong, I need to get the IT team to fix it. And we have two different teams. And there can be a lot of animosity, or there could be power struggles between them. And it just slows down development. So the idea of DevOps is that the IT team, either what used to be called an IT team, you divide it up. There is no IT team. You take one person from the IT team, you stick it with one developer group. Take another person from the IT team, you stick it with another developer group. And now that person is the DevOps person. And he's in charge of making sure that all the containers are working correctly for this team. And all the infrastructure is correct. And when you finally need to deploy the software, he's in charge of deploying, he or she. Now you could, if it's a small company, you might have just one team. The whole company is one team. But then the DevOps people should be integrated with they should be all working alongside and in tandem with the developers. Not like they have their different office and they don't know how the development is going until they're called in. They're there all the time. So using containers is like part of the theory of DevOps. Because
How do you even get one?
because it's because you, how does it go together? They just sort of develop at the same time, I think. Because if you have a separate team, then you're right, you could have a separate team that's gonna be in charge, but they don't know the need, they're gonna have to create different containers for different groups, maybe. You could have that, there are places, actually, my wife works at a place where they're doing it wrong. And they have a DevOps team who is like a separate department who services all the other teams that need stuff. But that's the wrong way of doing it. It's not the way it's supposed to be. Because then they say, and you ask for a request, they say, well, we don't want to do that. You know, because they're not in the same team. Did we talk about agile and stand-ups? In this course? So, what? Scrum meetings, yeah, so in the morning Scrum meeting. The DevOps person will be there, he's part of the team. So he knows the needs of the team, he knows what container, how should the container be. It could be done without containers, but it just sort of works together. I can't really explain better than that.
It helps the DevOps.
It makes the DevOps job easier, so then it's easier to have one person doing it, maybe you can say it like that. Alright, so there's a few concepts.
Sounds like
Malcolm, can you contain yourself?
In a container.
And also Mr. Tusk. Guys, I want you to be, I can't really talk while everybody's. There might be one or two students here who are more paying attention and they have a difficult time here talking. And I have a difficult time. Infrastructure as a service. So this is I mentioned this a little bit before, this infrastructure, platform, and software as a service. which means software as a service or SaaS is that you, like I said, I just want a service like your software product runs on the cloud, is accessed by users through. In other words, but see, the problem with this chapter is there's two different ways of looking at cloud. One way of looking at cloud is, I want to build the cloud. How do you build the cloud? And another way of looking at it is, I want to use the cloud. How do I use the cloud? So if you are building software as a service, then your software, you're not using it, you're the supplier of software as a service, then your software product runs on the cloud and is accessed by users through a web browser or mobile phone. In other words, you create a service like I said, checking, charging credit cards. You have a charging credit card service built in the cloud, and you sell your service to people who want to use that service. That's one thing that a cloud can do. Another thing a cloud can do, is the PaaS, platform as a service, which means in your cloud, you intermediate level where you use libraries and frameworks provided by the cloud provider to implement your software. These provide access to a range of functions, including SQ. In other words, right? You hire from the cloud a platform, and which means it's something that has in it services like SQL. SQL is not a service like the bottom of service as software as a service, because SQL in itself is not a service. It's something that I can use, infrastructure. I can use the database now to build a service, but it itself is software, which we call a framework. And then there's infrastructure as a service. The cloud providers offer different kinds of infrastructure services, such as a compute service, a network service, a storage service. Here they just give you, for example, just a disk, and they give you a CPU. And you have to decide what you want to do with that disk and CPU. You want to install an SQL server? That's your business. You're not buying an SQL server. It's cheaper actually to get the first one, just infrastructure. I want to buy from Amazon just a machine. I'll install my own Linux. I'll manage it. I'll do everything. I'll install on top of that, once I get it going, an SQL server. And then once I have an SQL server, I'll start providing services to people. I'll build on top of that a credit card company. And that I'll do it all, and all I did was buy the infrastructure. That's the cheapest way to go. But it requires the most work for me. Instead, I might want a installed server with all these services with SQL. Now, if I get that, that means that anytime my SQL server software gets updated, it's not my job to install the new update. Amazon will do it. In the first level, the top level, I would have to do it. I just got hardware from them. I have to take care of it. Here, I'm getting a guaranteed SQL server that's updated and taken care of. And then the final level would be that I don't even get that. I just ask them for a service. I say I want, for example, a website service that has email and domain name, and I want everything. And then I'll build a website. But I want all the services for my website that they're doing. There's different levels of requests that you can do with AWS. Here he gives an example. Everything as a service, software as a service, platform, infrastructure, cloud, data center. So this is the levels. Below, in other words, the cloud data center can have on an infrastructure service. What do we mean by everything as a service? It means that even when I get infrastructure, it's not that I'm physically getting infrastructure. I'm getting, like we said, a virtual machine. So it's a kind of a service. They're providing me, not giving me a piece of hardware, they're providing me the service that I get the feeling of computer virtualization. They're using here database software development because I got a database here. And here, like software, photo editing. I'm actually buying from them photo editing. The service already built, I'm buying. I can buy any of these levels.
Software as a service is actually something that is user facing. Let's say,
Well, it could still have an API, it could be an API based, it could be that. Like I need to access it through an API.
let's say if I buy a WordPress host, is that software as a service or platform?
No, that's software,
That's software.
that's for sure software, yeah. You're saying if I pay for my WordPress site. Or if I get it for free, I got free. I would call that software as a service. And then on that I can build more software.
Like, cause they provide WordPress installed and I'm just building the website.
Right, it's not like the middle one where we saw that I'm getting just like a data, an SQL, and I gotta manage it myself. I can store things, for example, if people post things on my WordPress, comments. It's being stored in, let's say, in a database, but I'm not managing the database, I'm just I'm not hiring a database from them, I'm hiring the service of taking care of all the posts. I don't care if they use which kind of database, I don't care.
Right, and like I'm not touching the Apache server that's running it, I'm just using it as writing the software.
Right. I'm not worried about, I don't know how they did it, I don't know what ports they opened, I don't know, I don't care. I would call that software as a service. But I'm thinking also of software as a service with an API, in the sense that. As a programmer, like how do you, when you charge somebody for their credit card, you may be on this website and you type in your credit card information. And they say, wait a minute, and they come back and say, approved. What they actually did was they made a call or remote call to some other company to approve that. And then they got back to that other company response and they told you that that approved. You didn't see that transaction. You didn't see them doing that. How did they do that? They do that with an API call. They hired a service from some other company. They pay a monthly fee or a percentage of the transactions. And they use API, which means they run remote procedure calls or remote function. They send messages over the internet, encrypted messages, and get back responses. Whatever method they use, wherever they send it. Here he's explaining who's in charge of managing it. Your infrastructure as a service. Then the basic computational service is going to be managed by the cloud vendor, but the cloud management services are managed by the software provider, managed by the software application. I guess, if I'm just getting infrastructure, then all I get is infrastructure, and everything above that I have to manage. If I'm getting what about platform here? Platform, I get two more, or I get all this done by the cloud vendor, and all I have to do is the service. All right, whatever. The basic idea is how much is managed. Like I said, how much is managed by the cloud provider, and how much is managed by me, the purchaser. Increasingly, software products are being delivered as a service rather than installed on the buyer's computers. In other words, what's an example of a service that anybody uses?
Spotify.
Well, Spotify is interesting because Spotify, I actually do install the apps. The apps are interesting because they're kind of client server protocol. I have a client. Some of the work is done by me, right? I have an app on my phone. It does some of the work. Maybe, for example, if I'm offline, I can still search for some song, because maybe it stores some of the data locally. Maybe I'll still see the previous songs that I saw. If it would like this, right? If it were a complete service, then I would always need to be in touch with the service provider. I would need to, it would be like like an online terminal. If you know, in Linux, you can get an online terminal. You can go to a website and you have like, you're connected to a machine through your web browser and you can do programming. The minute your connection is gone, you don't have anything. You have, it's all done through passing messages. There's nothing by me. So that's a complete service. I would call, that's a service. I'm asking for, provide me with an interface for, I mean, it's a kind of infrastructure, but it's not a real infrastructure because it's not permanent. I can lose it. That's what I was saying. I didn't like that example so much. It sounds like infrastructure, but it's really application. But think about your course in computer architecture. You downloaded a simulator to run your assembly commands. And that was on your computer. So that's nothing. That's none of these examples. That's just downloading, that's just getting some software installed. But imagine that there was a website that you could type your programs in the website and it would run them and give you the responses and you did it all on the web. So that would be software as a service, right? You're not, even if you have to pay for that, you're not paying for the database, you're not paying for the operating system, you're just paying for the service that they're providing you, the ability to compile programs. So increasingly so are we delivered as services rather than installed on the buyer's computer. The simulator in for MIPS was installed on the buyer's. If you deliver your software product as a service, you run the software on your servers. And then your service in turn you probably rent from a cloud provider. They have a weird thing like this that like I worked for a company where we were selling stuff, we were basically competing with Amazon. We were selling stuff that Amazon also sold. Where were our servers? Who did we rent our servers from? Amazon. So we were, and Amazon didn't mind because Amazon said either way we're making money. You want to sell it and take away business from us, but you're on our cloud, so we're making money from you that way. It wasn't really, I mean, in a sense it was a competition, but in a sense that we were, the more we developed, the more we needed our servers. So anyway, but it was kind of ironic that we're renting from Amazon and then only to compete with them. Of course, you can't compete with Amazon, so the company went bankrupt eventually.
You were selling the servers.
No, we were selling products, mail, you know, just like you buy stuff on Amazon, you can buy stuff from you could buy physical items and have them shipped to your house.
What was it called?
It was called Abe's Market.
Ames?
Abe, he named it, the guy who started named after his grandfather, who's named Abe, Abraham. But this existed, but you might be able to find it. It was bought out by somebody and.
So
No, not by Amazon. It's like iHerb, you know iHerb? You don't know iHerb?
Ames Market.
You know Vita Cost?
Is it like a bear with chocolate?
Yeah.
This is your company?
Yeah. But it doesn't really exist anymore. If you got a web page, it's just like it's just somebody bought the name. Anyway. So if you deliver your software as a service, you run the software on your servers, which you may rent from a cloud provider. Customers don't have to install software. They access the remote system through a web browser or a mobile app. So I guess you're saying Spotify is a service, but it also requires an app. It's kind of I consider apps to be like a combination. It's not a pure service, but I guess it's a service. You're paying for a service, but you have to have the app to run. But I guess it's still they're providing you with a service. They're just not providing you with the service. They're providing you have to have an app, and then your app has API connections to get the service.
It's not a full remote service.
It's still a service, right? It's a service that I access through API calls that my app is making and receiving data. The payment model for software as a service is usually as a subscription model. Oh, like you pay monthly for it. Because otherwise it would be really weird. Imagine if you just paid like $100 and now the rest of your life you have Spotify, so then they go out of business and then you lost your money. They can sell a lot of. Services by their nature have to be a subscription. As opposed to software that you download, you could pay for it, you bought it, now it's yours, you don't care if the company goes out of business, you have the software on your machine. Users pay a monthly fee to use the software rather than buying it outright. Software customers, there's the cloud infrastructure and there's the service, so you see, it could be that Spotify has all their servers are running on Amazon cloud for all I know. Or Microsoft cloud, I mean, who's the other, or Google's cloud, those are the three main ones.
Obviously.
Microsoft has a cloud service. Okay, and Amazon. So what are the benefits of software as a service? Cash flow. Since you're getting subscriptions, you're a regular cash flow, every month you're getting money. You don't have a situation where you get a ton of cash which you don't know what to do with, and then you get no cash, you have a constant flow and you know how much staff to have, how much workers to have. You are in control of updates. If you sell the software, then the person can be using some old software for years. But now I can, if it's a service, then my updates I do by Spotify updates their service. They may even update the app. And I can keep control of that. It's also easier, I don't have to send out like in the mail CD-ROM so that they can update get their new version. Like I have the Shoot Bar Ilan project, the Shoot project, Bar Ilan,
The shoot,
You have no idea.
and responses, yeah, and they keep every few years, they add some more text to their compilation of text, because they keep working on it. So but I have a disk on key with the whole program and the thing, so what do you have to do? There's no way that I can get the new version, I have to go with the disk on key back to them, say, here, I want an upgrade, I pay them 100 shekels. And then they give me the newest version, but I have to be with it, and I trade in the old one, get a new one.
do they have like a center you can go to?
Yeah.
Where?
I don't know, no, I never did it, I have one from like 4 years ago, 5 years ago,
Where?
one day I should go, I don't know, well, I don't know actually,
I have a guy, if anyone's
who you can exchange with,
not exchange, buy.
but I wanna do, I put upgrade,
The discs from? Oh, yeah, no, the upgrades are,
what?
upgrades are annoying.
I don't know how you do the upgrades.
But you have a guy who sells the bar and lot.
He also sells Bloodstone boots, right?
Yeah, we all have to have that guy.
He sells Bloodstone boots.
We were probably talking about different people,
And
but we all
Bar
have someone like that in our life.
and Barilan subscriptions,
I need someone like that.
and
I mean, it's like 1,000 shekels.
Shai, will you be my guy?
Actually, I think I got one for like 800.
yeah, they're like,
No, I too would.
And I sold it
I
for
don't need to buy it, it's just what he does, he does sell.
but the real one, yeah, there's a better one called Otsar Chokmah, which has much more stuff.
Is that better? There's also, it's very political, what they put on it and don't put on it.
Well, Otsar Chokmah,
Also, Chokmah is online, and also if you're in Bachon Level, you get free, like.
you get it for free?
Yeah, like a free.
Apparently we get free Microsoft, whatever,
How do I
right?
get
And that-
Oh, you're right, in the library,
No, I think it's less complicated, I've tried to like some complicated, but I think it's easier than I think there is not that complicated. You just log
anyway,
in.
yeah, well, actually, I needed something there, okay, anyway, really,
He's a little guy,
I should ask the
he's a
librarian.
big guy, huh?
And then there's something called continuous deployment, nice term, CD they call it, continuous.
Do you put them all?
Deployment means that every time there's an update, I saw something like how many updates Amazon does a week, it's like in the thousands. Every time some programmer improves something a little bit, so they just send it out and they update everybody who's using their app. So your app is constantly updating all the time. And that's good, that gives better reliability, bug fixes,
Deploiement.
that's continuous deployment.
Yeah.
Also, you get payment flexibilities, which means you can have different prices for different types of people, different needs. You can try it before you buy, right? If you just gave them the software, then they would never pay for it. But if it's a service, then you can cut it off after a certain time. So you can let them try it for some days. They used to have like, it used to be that you would be able to, they used to sell software with a 30-day key, and then the key would expire. And then you couldn't use it anymore until you paid them for the proper key. And then people would try to hack it, and there would be like people that would go on and try to get a key. I don't know, it was never, the system worked pretty well as far as I never was able to hack it. You can easily collect data on how the product is used and so identify areas for improvement, right? You can see, wow, everybody is using Spotify for country music, we better increase our country music library. Or everybody in Russia is using it all the time, we better put more servers in Russia. But you do want to have some of your servers local. Possibly. When you hire from the cloud, you actually can specify where you want your server. So a lot of companies, the smart thing to do is to say, I want some servers in California, and I want some in Peru, and I want some in Thailand. Because in case of an earthquake in California, and the service center goes down, I want to have the Peru one work. Also, I may have a lot of clients in Peru. If they're all going to California for their connections, it'll be slower.
Is that like something you consider even for school or just like a huge company?
No, I think even a small company,
If
they'll
I
have,
was small, I buy 25 servers.
yeah, spread them out. That's the whole thing. You don't, it doesn't cost you anymore.
Make any difference to you.
You can just say, I want 5 in California, 5 in New York, and 5 in England, and 5 in France. And then you gain something about security. And you also, okay, that's a different point that I'm saying. It's not written here. So here's a summary of some advantages and disadvantages of software as a service from the customer's perspective. The customer's advantage, for example, reduce software management costs. Why is that from the customer? Mobile, laptop, and right, once I pay for the service, I can use all my machines for it. No upfront costs, I don't have to pay upfront costs, I just pay monthly. Immediate software updates, I like that. Reduce software management costs. If I would hire this, if I would download the software, I might need to hire somebody to maintain it, to make sure to get updates. I don't have to maintain, I don't have to pay. What are my disadvantages? Oh, that's Mincha? All right, we'll stop here.
One alarm night.
Starting again,
We call it DDR though, protocol DDR.
we're continuing where we were.
You call it CCP. Yeah, what's it up
There's another issue which is called regulation. Some countries, such as EU countries, have strict laws on the storage of personal information. Quiet, guys. Rachamim. These may be incompatible with the laws and regulations of the country where the service provider is based. If a service provider cannot guarantee that the storage locations conform to the laws of the customer's country, businesses may be reluctant to use the product. In other words, if the European Union has some kind of strict data rules, and they do, and I'm providing a service to somebody who happens to be in France, well, then I all of a sudden need to follow their rules, but I didn't know that because I didn't know he was in France, and my company is in America. So you using a cloud can cause troubles. If a service provider cannot guarantee that their storage locations conform to the laws of the customer's location, then businesses, I mean, I guess the customer can choose to use it anyway, but a business may not want to use the service.
It's alternative.
The alternative, you use a local service that does conform, in other words, use a cloud that's in France. If your company is in, if your company, let's say I open a company and I want my cloud to be on Amazon, and I'm in France, and I'm providing people email service. And I'm doing this through the cloud, so all of a sudden, but American clouds are not conforming to European cloud rules. So I can't use Amazon, I have to use some kind of French cloud.
How do you say cloud in French?
I don't. If-
Nuage,
what?
love that.
What's the word?
Nuage,
Nuage.
nuage.
If software use involves a lot of data transfer. We have an issue of speed. So we may want a local cloud again. Also, if the data is, these are all reasons not to use the cloud. If the data is very secure, if I'm the Department of Homeland Security, I may not want to store my information on the cloud. Because the cloud is like, you know, is so owned by some company that's not the United States government. Data exchange. Sometimes if you store all your data on a cloud, then the data, you can only export the data in certain formats. What if I want to transfer my data from like the cloud to a new cloud company? Say, sorry, we don't provide a way for you to do that. And you have to download it to your servers and then upload it to them. We won't, if you want to migrate from one company to another, they may say, sorry, Charlie, we don't do that for you. So it may be better for me to have the data by myself, then I can choose where I want to put it. First, probably they have a way of downloading the data and then uploading it. But that's could also be cumbersome. That's what I'm saying. Ideally, you would want Amazon to be able to just forward all the data to Apple's cloud. But they may say we don't do that.
The data exchange is an issue anytime. Some software solution, whether it's a local software.
Right.
Still lock it into whatever file or.
Format, except that, right. Except that if I'm in control of it, I can probably, manipulate it. It depends, right, anytime I use any software that somebody else wrote, right, you may not have an export function. Well, that's a consideration to consider. Well, these are issues. So these are things to consider when you hire Amazon, and you should ask them, well, wait a second, can I get my data back, and in what format's can I get it back? And can you guarantee me that for 5 years? In other words, maybe they'll change their policies. I'm gonna skip this section. These are design issues. Well, actually, no, I won't skip this. Local, so SAS issue, design issues 1. Local versus remote processing. Some features can be executed locally in the user's browsers or in a mobile app, and some could be on a server. You have to decide how much do you want the app to do, how much do you want the server to do. Local execution reduces network traffic. Obviously, if we do it on the app, we'll have less traffic. So the user will get faster responses. But local processing increases the power made, the mobile phone may run out of battery power. So there's always a give and a take. There's no such thing as a free lunch.
I like.
Authentication. If you set up your own authentication system, so then users have to remember another password to use your system. So you could use Google's or Facebook's credentials. Then you have to have a method to communicate with them. And we have such a thing called federated. Right? Anyone know about this? I think it's called federated authentication. The word is federated or federation. But basically, you're saying you trust Google. Both of us agree that we trust Google. I let you, and Google will then give certain information of mine to you. I tell Google, yes, it's okay for AliExpress to know my name and my email address, but they're not gonna get my password, but they're gonna know certain information, and Google will pass it on to them. And then when I try to log into AliExpress, they'll ask me, do you want to authenticate with Google? And I'll say yes, and then they'll ask Google, And Google will say, well, since Nachum is logged in already and has a session going. We can confirm that this is Nachum. And then if I try to log in again, but I'm not logged in, they'll say, Google will say, no, we can't confirm this is Nachum, and AliExpress won't let me get into Nachum's account. And if I log in as Moshe, then I could, if Moshe left his machine on, logged into on my computer, now I can be going to Moshe's AliExpress account because they'll check, oh yeah, this Moshe's here. For which business products? Oh, here we go. That's what I say, federated authentication system. Which delegates authentication to someone else like Google. There's also a problem of information leakage. Because you may have multiple users from multiple organizations. In other words, if I'm providing a photograph printing company, let's say, I print wedding pictures in little nice booklets. So people can have a book of their wedding pictures. An album, well, a book, mamish a book there's printed. It used to be that albums had like little corners and you paste the corners in and the picture stays on the page and you actually have a physical picture in the, now you just print the picture as it was in the page. So it's a book. There are a number of different ways that this can happen. Well, but what if my pictures are uploaded, my wedding pictures are uploaded in your wedding pictures? Now, maybe somehow there'll be leakage and you'll see my pictures and I'll see your pictures. There's such a thing as a multi-tenant and multi-instance system. A multi-tenant system, all customers are served by a single system and a multi-tenant database. And a multi-instance system, separate copies of the system. We're gonna talk about that more. There's two basic ways to maintain data separate for different clients. So you have a multi-tenant system where you have one, think about it like this, one table, one database table, but it's partitioned. So you have your space and I have my space, but we're all in the same table. There's what we call one database schema. You ever heard the word schema?
Scheme.
Well, look, there's an A there. It's not a scheme. Scheme would be spelled with an E. Jeremy. See that? There's an A here. It's pronounced schema or schema or schema.
Schema.
Schema?
Yeah, scheme is spelled the same, just.
Scheme is with an E at the end.
Yeah, so schema.
Schema. Well, in Hebrew we say schema.
Schema. Yeah. No, that's fair.
But in English, you say, I don't know how you say it in English. I thought it was schema. But I guess no ch in Hebrew English. It could be schema. Anyway, a schema means like how you define the data, what data types you have, how many datas you have in the table. Items in the database are tagged with a tenant identifier representing a company. So let's see an example. Here is an example. Look at this. We have a table. Everyone sees this table? We have a table and look what it says here. Let's understand this. We have the tenant number and notice that tenant 516 appears several times. And he has key, notice that key 100 appears several times. How can that be? We know that a table has to be unique keys. How can we have this? Well, the answer is because the tenant number is different. These 100s, they all have different tenant numbers. 516 has a 100 and a 110 and a 120. Wait a second, what about this one? This is T tenant 973 and tenant 973, also key 100, key 100. That seems problematic. Is that a mistake? I'll say that's a mistake for now until
Maybe the item is
maybe the item is also part of the identifier?
maybe it is the.
Unlikely,
Yeah, I see. Very unlikely.
very unlikely.
Is there anybody on the board with playing computer?
This is the stock, how much there is of it. This is when it was ordered, this is who the supplier is. Fine, so you see here, we have one schema and multiple tenants. Why do I say one schema or one schema? Because there's the same number of columns, the columns types are all the same. In other words, it's not like one. Client has a different. Number of fields in the table, they all have the same number of fields, the same types of. So what are the advantages of a multi-tenant system? This provider has control over all the resources and can optimize the software. It's very easy to optimize your database if it's one database of one's type. If you have a mixed database, it'll be hard to optimize it. So here's a weird thing he says about security. Because we have everybody all together, we have to be extra careful about security so that I shouldn't by some weird method access the data of somebody else. So once we have to spend extra time thinking about security, we're gonna end up having a more secure system. In general, we'll be more impervious to hackers. Because we'll put in extra security measures naturally. Because the data for all customers have the same database, they are therefore likely to have fewer security vendors than standard database providers. Security management is simplified as there's only a single copy database software to be patched. I guess what he's saying a different point. He's saying the point that I said he does mention, but not here. Here he's saying a different point. He's saying that it's like putting all your eggs in one basket. Then I can just concentrate on securing it. I have one table, less things to secure. I can be more careful about it. It's easier to update the database because I have only one database. Okay. But the disadvantages are that it's inflexible. What if I need more fields from different from my from the other customer? The security issue, he says in particular, is that if it is hacked, then I'm hacking everybody. I don't spread out my risk. Did I tell you my story about putting the money around the room? When I was on vacation? I was on vacation on Shabbos and I couldn't lock the door of the hotel because it was electronic lock. And I wanted to leave. But I also couldn't carry my money with me because it's Shabbos. So I had to, and I hadn't put it in the safe ahead of Shabbat. So I had this money. I don't know if there was a safe. I don't think there was a safe. So I had this money and I didn't want to carry it. I leave it in the room and with the door open. In the hotel, which is kind of a weird situation. So what I did was I said, I'll put the money in different locations in the room. And that way, if somebody does come in and looks for the money and finds it, he'll probably find one and say, I found it, and then leave.
You're a goddamn genius.
And if he goes through the whole house and tries to look for all of them, he probably won't find them all. So at least I'll have some money. And then of course I put my passports in different locations. Never put your passports with your money. Because then if the guy steals your money, he might just grab the whole thing and take your passport. So always put your passports with no money. Anyway, that's called spreading the risk. If you put, so here we have all the data in one location, it could be risk complexity. Multi-tenant systems are usually more complex than multi-instance systems. So let's talk about multi-instance one. What is this? Possible customizations. I can't read that. I mean, get rid of this. Possible custom authentication. Business may want to use their own authentication. Branding. Business may want their own user interface. They don't want. They're using your web server. Your email service, like Google. Machon Lev uses Google email service. But when you go in, you wouldn't know it. It has the label. The entrance label looks like Machon Lev, and even the email extension. After the @ sign, doesn't say Google, it says showing GCT. So you can use a service, but you want branding. Business rules. They may want to define their own workflows. Data stems, they may have their own data, like we said before. Access control. We may want to have their own specific access controls, like certain people can access this field and certain people can access that field, and maybe the service was not designed for that. Here we have different profiles where we could have different accessing based on different profiles. The different users are set up with different profiles and they have different abilities to use the service based on whatever profile they are assigned. All right. Here is an idea of Nachum. Can you make less noise? Also Rachamim.
I think Rob's.
Don't let him rob you, but please don't make any, also don't let him make noise.
I'm trying to put my bag.
Okay. Look at this example here. Here, we enable, we have a single schema or schema, but we allow people to have their own fields because we have extension 1, 2, and 3. So that means that a tenant 516 can have extra fields if he wants, because we built in some spare fields. That's one solution. What's the problem with that solution? What if he needs 4 fields? It's always limited. We don't know how many to add. Most people won't use them. Since most people won't use them, you have a lot of extra data here, a lot of extra space that's just empty. You make all these and most people don't need them. And only one guy needs it, so you wasted it for everybody. Also, the column headings could be different. I could want this extension to be the string, and you could want it to be a number. Of course, you could put everything as a string. Every string is the most universal type of. You guys all learn databases, right? String is the most String is the most universal type of type because everything is a string. The number 17 could be a string. The name of a person, a date could be a string. Everything could be a string. So you could just make everything a string, but then you lose efficiency in searching. When you know what type it is and it's not a string, you can search in a different way. The searcher. See, why do we have databases? Because they're designed to be fast at searching. So how can you extend a database? And here we're going to see an example. Here's a better solution. Look at this. It's a little bit complicated, but this is a nice thing. We have our original database. We only add one extra column. And then we say for ID, for tenant number 516, for ID number 100, he uses extension E123. So here is extension E123. And now what we do is we say, this is for tenant number 516, which it is, and here's the value, some kind of weird value, A17 divided by S6. So we have the tenant and the value that he wants are there. We also, wait. Record E. Yeah, but look, the value is, how many values are there? There are 3. Notice that it's 3. He's got the A17/6S6. He's also got 4, and he's also got false. In other words, once we've found the beginning of 123, the truth is we don't really need the tenant here. There's only one E extension 123. Is 124 will be the next one. Well, we don't see that here, but 200. Do we see 200? Here, extension 200. Comes to here. And then all these things are in 200. This date and this string of city. And then what about 3? Here, his extension, only one piece of information. Now, what are these? These are the values, but what type are they? So look what I can do. I can say that for tenant 516, his types that he needs are location, weight, and if it's fragile. So this allows me to determine that this is location A17. The weight is 4 and its fragile is false. Those are the field columns for 516. Who's 516? Tenant 516. So when he said go E23, I went to E23. And I see that it's 516, well, it has to be 516 because he's the one who's pointing. I guess that's like an added security measure. And now since it's 516, I go here, there's only gonna be one type of extension, and that's how I know also that there's only three. Because I see there's three here. And T632 has two, delivered, which is a date. And even though I'm storing the date as a string, I write over here date so I can convert it. And place is a string for sure. Delivered is a date. So you understand how this works? This is like a, I don't know if we did something like this before. It's kind of like a linked list. I have a single pointer here. And then that points to another field. And it tells me how, and I know exactly how big it's gonna be. So I can have basically different schemas now for different schemas for different tenants on the same table. How? By having a single table with just one extension, just a pointer here. And the pointer tells me where to go, and then here I have a table, I just have two more tables, no matter how much I have, I just have two more tables. One table, which one in general will be bigger? The field names or the field values? In general, what?
Guys.
Right, because the field names is just the definitions of how many fields each client has. And what their meaning is, but that's gonna be one time only, I'm never gonna have 516, that's it, 516 is not gonna appear again in this table. This is it, 516 is here, and that's it. But here, 516 could appear thousands of times, depending on how many times he appears in this table. Every time 516 appears here, there should be a new record for him over here. With a pointer to the beginning of where his records are. So now this table, I don't have any wasted space, you see that? I have no wasted space. In the previous, if I would have just added three extensions, then I would have a lot of wasted space. For example, tenant number T973 only needs one extension. So I have no wasted space here, basically. And I can have as infinite different kinds of schemas. So that's how we use a tenant database to give us the feel that we have in new instances of the database.
The databases aren't only lists, like how do you know that you pull up those three items from E123 and it comes in this order and matches those.
Oh, it's always done like that. In other words, tenant number 516, he wants these 4 fields or 5 fields, 6 fields, and he also wants these 3 more. So every time there's an entry in 516, there will be 3 more fields and they'll always be specified here. Always, it's not like he can change it around sometimes like this, sometimes like that. He comes and tells us, in my table of products, I want my products to have this many fields.
So we're assuming the database has implicit ordering of them.
Well, I write here a number and then it finds the number and that's always the first one. And then it just counts.
Right, but how do we know that this database will always return it in the order of location, weight, fragile, and not in a different order? If there's no order by. Or there's nothing in here to tell it how to order the.
No, I understand. When you do a query, and you order it differently, that's your business, but.
How does the database even know what order?
It knows that the order, the way it stores it is that it's in the order as written here. Location, weight, fragile. That's the order that has to be written in over here. Can't switch that order. And it knows whatever is in the first place must be a location. So
If I was designing, I would just add the name for simplicity. The name of the field in the values so that you have the record.
you're saying, why not just have one more column over here.
Yeah.
Well, it's because it's a relational database. If in a because this table, field names can be much smaller. The whole idea in relational databases, as opposed to no SQL databases, is that we want to do we want to have the rest of the data, we want to have data only once. Your way, I have to have, by every entry of 10 at 516, I would have to repeat string, integer, boolean, because,
Just the name of the field so that it.
or location,
Correct.
or location, weight, fragile. But there's that location, weight, fragile, location, weight, fragile, location, weight, fragile, many times. And it's extraneous, I don't need that, I can get away without it.
I guess it depends on who got that.
Yeah, we're just talking theoretically, we're not talking about how, we're not worrying about how SQL or how MySQL is gonna implement this. But this is the concept. I mean, it's real. It's not just, you know what I mean, I'm not making this, it's theoretically possible, but he's saying this because people do it, this is done. Anything in these slides is about the real world. We always want to have multi-level security. What do we mean by multi-level security? We mean that in order to access the software inside the business, maybe we limit it to certain people and passwords. And then once they're in, we also limit the access to the database. Multi-levels of encryption of data in a multi-tenant database. So here's another thing we can do. We can encrypt the database table and totally encrypt it. And then each client can only he can unencrypt his own data. That provides another level of security. What about multi-instance? Well, here we just say each customer has its own database made for his own needs. Conceptually, it's simpler. Conceptually, it's simpler, and also it's easier to prevent accessing across from one client to another because they're on completely different databases. There are two types: virtual machine-based, multi-instance, which means that they're all on one machine, but they're virtually on different machines. And then you could also use containers again, where each user has an isolated version of the software and database running on in a set of containers. This approach is suited to products in which users mostly work independently. Here we don't have to have a shared database. Of course, there's a problem with this, that if everybody has their own database, the changes that one does won't be seen by another. So multi-instance databases are more flexible, more secure, more scalable. I can just make more servers. They have more resilience, but they're probably more expensive. You have to have a whole new instance just for every client. It's more expensive to use multi-instance because you have to have many virtual machines. More complex to manage updates. I got to update on all the different instances. Here are some decisions I have to make. Should the software use a multi-tenant or multi-instance database? What are the software scalability and resilience requirements? How likely am I to need to make extra servers from day to day? Software structure, should the software be structured? Be monolithic or service oriented? Monolithic means should it be one program, or should I make my program use lots of services from the cloud? What cloud platform should be used for development and delivery? In other words, should I use AWS or Google? Question to ask when choosing a database organization. The Customers have security clearance, alright, we have examples here. Transaction requirements, is it critical that your product supports ACID transactions? We talked about ACID last time, right? ACID transactions are atomic,
Yep, system,
consistent,
integrity, dependent lives. How did I do?
yeah, you did,
I'm Googling them. Durability, sorry, and isolation.
isolation. That's good, right? In other words, we want our transactions to be isolated from one another, to be atomic, they can't be interrupted in the middle. Dependable, is what we said,
Isolation and
durable.
durability,
Durability, I guess, means that the change that I do is permanent.
also like a washing machine. And it still is.
Database size and connectivity, how large is the typical database? These are all questions I need to ask before I start using the cloud. Database interoperability, will customers want to transfer their data from their old system to the new system? Does the new system support the old system? A system structure. Are you doing a service oriented, are you doing SaaS, service oriented architecture? Can customer database be split into a set of individual service databases? If so, use containerized multi-instance database. Alright, here's some summary points. Scalability of a system reflects its ability to adapt. Okay, where do we go? Oh, key points. Alright, I think we'll stop here. You can look at the key points on your own.
Don't give up, you're strong.
Don't give up.
Yes, the events, so did we just finish,